Hi, and welcome to my video on making a 3D interactive planet Earth using C++ and the OpenFrameworks Creative Coding Toolkit. And so ahead of time, I have already set up my machine with the required components. I have downloaded OpenFrameworks. It is a C++ coding toolkit, so that means we also need a compiler and IDE for C++. And so I have gone and installed Visual Studio 2019 Community Edition. And the OpenFrameworks instructions deal with the 2017 edition, but we're going to see that's not really a problem at all. The key thing is when you do install Visual Studio, you want to make sure that you have enabled desktop development with C++ as one of the options during the install. And so with those things already pre-installed, I can show you here. I'll just go to, this is where I have extracted the download of OpenFrameworks. There is a project generator for VS Code that I can use. So I'm going to open that up and run the project generator. I have, there's already a folder structure present in the download of the OpenFrameworks. There's an apps folder, and within there's like a my apps folder. That's where all of our apps go. And so that's what this project path is pointing to. I'm going to give my name of my project here. I'm going to call it Planet Earth. And it's going to go into that apps, my apps. I don't need any specific add-ons here, but if I wanted to add, something like 2D collision detection, I would bring in Box2D, or there's the really handy GUI library that makes setting up parameters, tweakable parameters quite easily, but I'm just going to keep things simple. Again, it does say Visual Studio 2017, but that's not going to be a problem. So I'm just going to hit generate. And it tells me that it's created it and that I can open it in my IDE. So I'll click open in IDE. And then here it's going to ask me if I want to retarget my projects. And this is just that the version of the SDK that the generator assumes that you have is the one that was bundled with Visual Studio 2017. So just to do this upgrade, we can just click OK to this retargeting projects. And that's all we need to do. I'll just click a few things just to get things going. I want to change the compilation target to be x64. I found that if you don't switch that over, it won't run properly on a 64-bit version of Windows, and that's the operating system that I'm using. And so if I just click run here, there's already sort of a scaffolded OpenFrameworks application that doesn't do anything, but I'm just going to go through the process just to make sure that it compiles and that it runs. And all it'll do is it'll open up a console window and then like a graphics window, and then we'll see that the graphics window is just empty. So here's the sort of the empty 2D graphics window that we're going to be writing our planet to. And that means everything's working. There was no compilation errors. If I go to the Solution Explorer over on the right here, I can look at my Planet Earth source, and I can see that there's two files that I'm going to be doing most of my work in. The app CPP file, and then the app header file. And the app header file gives us an idea of what the CPP file looks like. There's going to be a few different public functions that we're going to implement. If you're familiar with the processing or processing.js creative coding platform, it's fairly similar. You have three primary functions that you work with: a setup, an update, and a draw. And the whole goal of OpenFrameworks is that it's going to be running this draw over and over and over, effectively as fast as it can, or to the frame rate that you specify. It's also going to run this update function where you can update things before drawing them, and then this setup function is going to run once at the beginning of your application. So I'm going to go in here at the bottom of this file and just add a few different variables that I want to make use of inside of this class, inside of my program. And so I need a sphere onto which that I can put the texture of the planet Earth. So I'm going to say most of the things in OpenFrameworks start with OF. So I'm going to say OF sphere primitive, and I'm just going to name that variable sphere. I'm going to create a few other things. OF light. That's going to be a light source that we're going to use to light our planet. So you can sort of think of that as a light bulb that's going to be placed within our scene. I'm going to use OF texture. And that's going to be the texture that we load up for the planet Earth that we're going to sort of wrap around the sphere. OF EasyCam is a built-in module that allows you to take control of a 3D camera and then use your mouse to zoom in and zoom out and pan around the scene. So I'm going to call that cam. And then last but not least, I think that's it. That's all I need is those 4 things at least to begin with. So that'll give me access to those variables of those specific types within my application here. So in the setup, which is going to be run once at the beginning when my program first executes, I have to do a little bit of setup work. And so one of the things that I looked into, I saw a few tutorials and followed a few tutorials to figure out how to do this. And they all had some form of setup that involved disabling alpha blending. I actually can't tell the difference between this being on or off, so I'm not sure if that one's actually required. So I'll put a little note here. Is this actually required? I couldn't tell the difference. We can toggle that on and off. This one is definitely required. OF enable depth test. If we don't enable the depth test, when we put our texture onto our sphere, it's going to do some very odd things. And so this, and I can show you that. I'll disable that or comment out that line and show you what happens without that in place. And then lastly, there's one other sort of setup that function that I need to call, which is this disable arb text. If we hover over any one of these, they give us a quick explanation of what we're doing here. And it says here that it's going to put OpenGL, which is the graphics library that's sort of sitting under the hood of OpenFrameworks, into 2D texture mode, which is the default for OpenGL, but wasn't previously the default or isn't the default for OpenFrameworks. But we need it to be in 2D texture mode for our textures to work properly. And so that's there. And this is there just sort of for backwards compatibility. When OpenFrameworks was first written, 2D textures weren't the default for OpenGL, and they didn't want to change their default and potentially break old OpenFrameworks projects. So you have to switch that over yourself manually. Okay, so the next thing I need to do is I want to load up an image of the Earth. And I went to NASA and I grabbed a texture of the planet Earth. And so I will show you that image right here. I grabbed a few of them, tried textures, quite small ones down to like 300K, really large textures up to like 30 megs. And so I'm going to grab these 2 textures here. One's like a 2 meg one, one's a 15 meg one, one's in JPEG format, one's in PNG format. And I'll put the location, the URL, just in the video description of where I grabbed these textures. And where I specifically want to put those is in OpenFrameworks. In that my apps folder, we have our planet Earth. And if we go into the bin folder, we'll see a data folder. And that's where we want to put the data for our application. And I'll probably just start with, I don't even know if I'm going to use this JPEG one. I might just use the PNG unless the PNG is slow to load. And so here I'm going to say OF load image. And if you remember the texture that I had created in the header file, I just called it texture. And so that's going to be the first of the arguments there is where to load the image, and then I just have to specify the name of that PNG in the data folder. So load image texture. And you know, if I wanted to here, I could run this and just make sure it runs without errors. Again, we're not going to see anything, but as long as this runs without errors, it'll let us know that OpenFrameworks has found the texture and has loaded it up. So there's no errors in any of our windows. That is good. And there's actually not too much more to it for the basic idea here. I'm going to go to draw here, and I'm going to say sphere.draw. And again, if I just run this, we're going to see where the sphere is drawn. We haven't yet textured it. You can see up in the top corner here, you can see what sort of looks like a circle. It's actually a sphere, but we can't really tell that it's three-dimensional. It's up in that top corner there. And we actually want it to be drawn into the middle of the screen, and then we want the ability to rotate around it, zooming in and zooming out. And so that's where our easy cam comes into action. That's this thing here that we've called cam. And so wrapping the sphere.draw inside of this draw function, and recalling that this draw function, OpenFrameworks is just going to call it repeatedly once per frame. Here I'm just going to say cam begin and cam end, and then everything within there is going to be drawn in reference to this camera that I'm going to have interactive control over. And so if I go and run the program again, we can see, look at that, there's the sphere. We can't yet tell that it's you know, 3D, but I can zoom in and out. There's my scroll wheel, so I'm zooming in, I'm zooming out. When you zoom it in quite a bit, you can see that, you know, the sphere is made up of a bunch of different polygons, and you can actually see some of that. You can sort of see the resolution of the lines that are forming the sphere, and we'll look a little bit closer at that later on in this video. But it might be nice to start a little bit more zoomed in, maybe like around like this, rather than having it like be a little dot to begin with. So what I will do up here in the setup is I will set up the camera as well. And so I'll just go cam.set distance. And I know approximately what distance I want because I played around with these numbers ahead of time, and I'm going to choose 50 for that distance. And that was just trial and error, figuring out sort of the distance that I wanted. And we run it, and that looks about right. Okay, and I can still zoom in and zoom out. We already have the texture loaded, so we can actually already map that to our sphere. And just like with the camera, where we sort of denote the beginning and the ending of the camera, we're going to bind our texture to the sphere with a texture.bind, like so. And then after the drawing of the sphere, a texture.unbind. And so that's going to bind our texture to the sphere that is drawn between the bind and the unbind. We run our program, and look at that. I can grab it with my mouse, I can move it back and forth, I can zoom in and out, I can zoom actually right through the planet. So look at that, I can sort of see through the planet. We might want to you know, set up some limits to our zoom level, but we get all of this functionality built right into OpenFrameworks. So there's very, very little code that was required to get this going. And we're just going to add a few things just to make, just for some niceties, because we're effectively done here. We've taken that image, which if we look at it, This is what the image looks like when it's not stretched out over a sphere. It looks like that. The image was designed to be wrapped around a sphere, so that's why it works so nicely right off the hop. And so you can see Antarctica stretched out all on the bottom there, but if we look at our actual sphere and you look at Antarctica, it becomes this landmass at the bottom there. Okay, so let's add some niceties into what we're doing here. One of the things that might be nice to add is just like a light, like a point source light. And so I'm going to make use of the light that we already have set up as a variable in our header file. And I'm going to say light.enable and light.set position. And again, a little bit of playing around here. Position takes either like an X, Y, and a Z, or a vector. I'm just going to give it an X, Y, and a Z. Played around with those numbers ahead of time. And then where do we want this light to be pointed towards? Well, the way that the EasyCam works is when we first drew the sphere without EasyCam, our origin or our 0, 0, 0 position was up in the top left-hand corner. With EasyCam, it's the sort of the center of the screen, but we still want the light to point to that origin, the sort of the 0, 0, 0 mark. And so we're going to tell it to look at 0. Now, does this take a... Looks like I might have to pass it a vector rather than an X, Y, Z, which is fine. I can just use the OF three-dimensional vector of 0, 0, and 0. And so before, let's just quickly show you the before so you remember what that looks like. So I'll just temporarily comment out and run this program again. What I want to show is this, that by default, the sphere is lit sort of uniformly. And so there's light sort of hitting all sides of this sphere. And the cam is allowing us to rotate around the sphere. So it looks like we're rotating the sphere, but what we're really doing is the sphere is staying in a fixed position and we're rotating the camera around that sphere. Let's bring the light source into place. So this is like putting a sort of a spotlight at a particular position and pointing in a particular direction in our scene. And there you can see we have light sort of hitting here. It's almost like you have the light from the sun hitting sort of on the edge of North America and over into Russia. But then we have, you know, some of the planet like Africa is in darkness right now. So that's again showing us that the sphere and the light are in a fixed position, and it's actually our camera that's rotating around. What I would actually like though is I would like the light to actually move with my camera, but not at the exact same speed. I want it to play a little bit of catch up, so that when my camera moves, I want the light source to move to the same position where my camera is, so that I'm always lighting up the where I'm looking. And so I could do that really quickly here. I'm gonna create a few 3D vectors by checking the position of the camera and the light source. So I'm going to say cam.get position, and I'm going to get the light position too. It's going to be light.get position. I need an F at the end of that. We are. So those are going to be those two positions, and if I'll show it to you. I was going to say if I wanted to, but I can just show you what I can do here is I can just immediately set the position of the light to the position of the camera. And so that's sort of an immediate setup. What don't you like there? Oh no, it's not the position that I want to set. It's the actual light that I want to set. So if we run this, it looks similar to how it looked in the beginning. Basically, there's a light coming directly from where the camera is. And as I said, I wanted to play a little bit of catch up. So I want it to not sort of snap to the camera's position immediately. And so the way I'm going to do that is this is an update function. This function is called every time right before the draw function is called once per frame. And so instead of just immediately setting the position, I'm going to check the difference between the two positions, the difference between the light's position and the camera's position, and then just move that camera every update a little bit closer to the light, and so that it just is playing catch up. So I'm going to say create another 3D vector, and I'll call it like delta, meaning the difference between, and I'll say it's the difference between the camera position and the light position. I mean, why make really small variables? Camera position, light position, and then delta is going to be the camera position minus the light position. And then for every 3D vector, I can check its length. And so I'm going to say, like, if the difference, the length is greater than 5. And again, here I've just sort of played around with numbers that worked. Oh, length is a function call. I'm going to change the light position. I'm going to take the current light position, and I'm going to add to it the difference divided by a large number. And again, playing around, I found that 50 was fairly good. So if I just said light position plus delta, well, again, that would snap it immediately to the camera's position. By dividing the difference by 50, it's going to slowly pan, and it will sort of ease at the last moment, because as the delta gets small, a small number divided by 50 is going to get quite small, and so it's going to move quicker at the beginning and sort of slow down as it approaches. And it'll be best seen when you actually watch this in action. Look at that, panning over. So I move here, it pans over there. If I move down here, it pans over there. Go to Antarctica, it pans to Antarctica. Go to the North Pole, it pans to the North Pole. So that's a nicety. And I think there's a few final things that I would like to do here. One of them is I'll put the Earth into motion. I'll start it sort of spinning around its axis. I'm going to do that within the draw function here, and I'm going to do that by way of a rotate method. And so right before here, we'll put cam beginning and end here, and here I will use OF rotate Y degrees. So I'm going to rotate around the Y axis. And in with our particular cam, our y-axis is sort of pointing up towards the top of the screen. So that's going to be the axis sort of the Earth. And here I'm going to get the frame number. And so that's just the number of frames since the program started running. And I'm going to use that as a rotation. So it's just going to be a number that's constantly increasing. If I just let it be at the number of frames, it would go rather quickly. So again, I found playing around 9 was a fairly good number. Let's make sure it's a floating point number and we don't end up with like integer math. And so if I run that, we've got the Earth rotating around, and it's still, you know, when I move my camera, the light source is still playing catch up, which is nice. This rotating Earth, and then if I don't do anything, if I just keep the camera pointing, then the light source is just going to continue pointing straight on to the Earth there. And then the very last thing I wanted to just show, because again, I think we're effectively done here, but I wanted to talk a little bit about the resolution of the sphere. And so I'm going to add a new variable here, and I'm just going to call it, it's going to be an integer, and I'm going to call it sphere resolution. And inside of the setup, I'm going to say sphere resolution equals, and I'm going to go to our sphere, that's the sphere we're drawing here, and get the resolution to see sort of where it starts. And there's all these event functions that OpenFrameworks will call automatically for us when certain things happen, and one of them is key pressed. And I'm just going to make it so that if I press 2 keys on the keyboard, we're going to put that resolution either to increase or to decrease. And so I'm going to say if the key is, and I'm just going to use the numbers 0 and 9 just because they happen to be side by side on the keyboard. I'm going to have 9 mean going down and 0 mean going up. And so I'll say 9. So if we hit a 9, then I want to get that sphere resolution and decrease it by 1. And then I'm going to go to the sphere and I'm going to set the, not get, but set the resolution using that sphere resolution. Otherwise, if the key is a 0, I'm going to do effectively the same thing, but increasing the resolution with a plus plus. And I guess in both cases, I will do a cout so that we can see that sphere resolution change over time. And so this is going to control the number of faces of the sphere. And so if I run this program, the default is 16. And 16 does a pretty good job of approximating a nice round sphere, but we're going to actually see that we can change that. And so here we are. Here's our sphere. If I move it over a little bit so that we can see this console, if I now hit my numbers, we'll see the numbers changing over on the left there. So if I go down to decrease the number by hitting the number 9, say it says 15, and every time I hit down, you're going to see the shape get a little bit more jagged. So we'll go 15, 14, 13, 12, 11, 10, 9. Now it's quite obvious, like you can see the side of the sphere, there's quite some straight lines involved. 8, 7, 6, 5. Now we're getting like that. It's not actually faces of the sphere because 5, there's more than 5 here. 4, 3. And so here with 3, how many sides do we actually have with 3? We have 1, 2, 3, 4, 5, 6 on the bottom, 6 on the top, and then 1, 2, 3, 4, 5, 6. So when it's 3, we actually have 18 sides. And then I can go down to 2, which is the smallest. If I go to 1, we don't get anything at all. So 2, we ended up having, it's 8 sides. And so that doesn't really look like the Earth. My camera's not working as well as it previously did. And you can see the mapping is quite odd. If I stay focused at the top here and start increasing the resolution of the sphere, you can see it gets better and better and better and better and better. And we can get it right back to where we started, which was 16, which again is it's a pretty darn good approximation. but we can actually see that, you know, we can increase it quite a bit more, and it will only stop, yeah, so maybe around here in the 30s. It doesn't seem to visually make a difference anymore to the sphere. So it's, you know, if I bring it down to like 30, that's pretty darn close to a perfectly round sphere, or at least the simulation of a nice perfectly round sphere. And so that's all I wanted to show for today, just how easy it was to get the planet Earth mapped to a sphere like this that we can rotate around. We can have a light source that follows our camera with a bit of a delay, and we can change the sort of the resolution of the sphere that we are mapping to. And so again, if we go back to the source code just to see what we ended up implementing, we brought in some aspects that are built into OpenFrameworks: a sphere primitive, a light source, a texture, and the easy cam. In the setup, we had to do a little bit of setup here. Oh, here, I'll quickly show you what happens if the depth test isn't enabled. The depth test isn't enabled, the texture gets mapped in a very odd way because it doesn't fully understand depth. So you can see here at the top here, I think we're seeing like through the image and getting the other side. And so that is a bit odd. And then as we rotate, so yeah, that's definitely not what we wanted, unless we want like a really trippy planet. And so again, I couldn't tell the difference between this alpha blending. So these are probably the two most important things that we had to enable. Then we enabled a light source at a particular position and looking at the origin, or sort of the center of our Earth. We set the distance for the camera, how far away we were, so that we weren't quite zoomed out at the beginning. We loaded up our texture. This get resolution was simply just to allow us to mess with the resolution of that sphere. In the update, we are constantly checking the position of both the camera and the light source, figuring out how different they are, and then forcing the light source to slowly approach the position of the camera. And then in the draw here, we use EasyCam to set the center stage to the middle of our screen and give us the ability to use the mouse to pan around. We are using the number of frames since the program started to rotate our sphere, and then we're binding the texture that we loaded to the sphere and drawing it. And then on key press, we had that ability to increase or decrease the sphere resolution. Okay, so hopefully that was a good introduction for you to how powerful OpenFrameworks can be. People are often a little bit scared of a language like C++, and you can also see here, you know, it's quite approachable. There hasn't been anything too odd that we've had to do. I mean, I didn't go over all the details that were C++ specific, but if you've had experience with a language that is sort of C style, so like PHP or JavaScript or C# or Java even, a lot of this should feel fairly comfortable to you. And so, yeah, check out OpenFrameworks. You can pick it up at openframeworks.cc. And again, if you are on Windows, you can download Visual Studio 2019 Community Edition for free to allow you to play around with it. All right, thanks everybody. Bye-bye.